Here we are with a little bit of help for lesson 3 or lesson 9 of unit 3 in your homework. Question 1, suppose that during its flight, the elevation in feet of a certain plane on its time, t in minutes, takes off are related by a linear equation. This is really important to recognize that we're talking about a linear equation because that means that everything that we talk about with this plane related to time and elevation will create a straight line graph. So consider the graph of the equation with time represented on the horizontal axis and elevation on the vertical axis. For each situation, select if the slope is positive, 0, or negative. So when we talk about these pieces, it might be helpful to go ahead and draw a graph, and where we see a coordinate plane, such as this, and remember the whole concept of whether that plane or what that plane is doing, whether that's increasing in elevation, decreasing in elevation, or just staying constant. So we talk about this plane is cruising at an altitude of 37,000 feet. So this is a really important piece to this cruising. When we talk about the cruising, the question is, do you see any change in elevation with this plane over any amount of time? Well, if I'm talking about a cruising value, we're talking about an airplane that's cruising up in the open blue skies, I think I'm just going to see a plane that's doing this. Just kind of staying static up there in the air, 37,000 feet in the air. So you'll have to make a choice on this one to decide, is that a positive slope, a negative slope, or a 0 slope? Okay, talk about the next one. A plane is descending at a rate. Let's go ahead and mark some keywords here. This plane is descending at a rate of 1,000 feet per minute. Think about descending. Does that have to do with the positive, negative, or 0 slope? And then finally, letter C, ascending with this slope right here. So decide with that. What does ascending, what does descending mean? If you're not sure, go ahead and Google it. Next question. A group of hikers park their car at the trailhead and walk into the forest to a campsite. The next morning, they head out on a hike from their campsite, walking at a steady rate. There's an important concept to talk about. They are walking at a steady rate. This is really important because a steady rate indicates that we have a constant rate of change, or that they're moving at the exact same speed over time. The graph shows their distance in miles, d. Let's go ahead and grab that one in one color. So distance in miles, d, from the car after h hours of hiking. So we know that d represents number of miles, h represents the number of hours. When we look at the graph over here, the coordinate plane, I think it would be really helpful for us to go ahead and label our graph. So d is the distance. And we talk about in miles, the abbreviation for miles is mi. And then right here, this is the number of hours or the time. So how far is the campsite from their cars? So we have to talk about this piece with it. They head out on a hike from their campsite and walk at a steady rate. The graph shows their distance in miles from the car after 8 hours of hiking. So we see that those campers, they're actually having to get to a certain distance before they actually get to their campsite. So we need to think about where does their value actually begin? And then complete the equation. The equation represents the relationship between d and h. So when we're talking about part B, d and h, we're talking about any distance over any given amount of time. And what we need to look at right here is we need to figure out what goes in this piece right here, what goes in this piece right here, knowing that we have this 3h already set up. Know that our equation usually looks like this: y equals m times x plus b. And I'd like to help you out with this case. When we're talking about the y coordinate, we're talking about which one depends on the other. So does the distance in miles depend on the hours of hiking, or does the hours of hiking depend on the distance in miles? When we look at our graph, we see that h is on the x-axis. So we know that the number of miles, distance, is dependent on however long we decide to go and hike. So y would be d, and m must be h, because those are the two. Whoops, just kidding. I put that on the wrong spot. Not m is h, because m has a numerical value. X is H because it's the X axis. My apologies for that. So, and I think that's the only questions. And there's one more question right here. Be sure to use that equation, that work right here for question B. Question C is using the same type of thing. After how many hours of hiking will they be 16 miles from their car? Well, if we're talking about 16 miles from their car, you can do a couple of different things. You can look up here at the graph and find out where 16 miles is and correlate that with the number of hours. Or you can use the equation that you wrote up here where distance is equal to whatever that blank space is right here, plus 3 miles per hour. So with that value, with the number of hours, of course, 16 miles, 16 would have to be the distance. So it'd be 16 is equal to that blank space you're finding right here, plus 3 times H. So give that a good shot. Question 3. Elena's aunt pays her $1 for each call she makes to let people know how much her aunts are about her aunt's new business. So she's working at a call center. The table shows how much money Diego receives for washing windows for his neighbors. So we have two different situations here. We have one situation where Elena's earning $1 an hour or $1 a call. So for Elena, she gets $1 per call. And then Diego, we're not sure about him, but we know that for any number of windows, he's making a certain amount of money. So in this case, Diego is looking at $30 for 27 windows, $50 for 45 windows, $90 for 81 windows. I think the most important thing that we should figure out is this a proportional relation or not? So when we look at this, well, that's pretty awful. When we look at this, let's see what happens when we take 30 27ths, 50 45ths, and 90 81st. And let's reduce these. We know that 3 goes in equally into 30 and 27. And so we can reduce that from 30 down to divided by 3 is 10. 27 divided by 3 is 9. 45 and 50, both of those divide evenly by 5. 50 divided by 5 is 10. 45 divided by 5 is 9. And for 90 and 81, both divide evenly by 9. So we see that in all of these pieces, they all reduce down to 10/9. So we know that this is a proportional relation because all of the y values vary directly as the x value. We have a constant rate going on here. What is that constant rate? Well, if we're talking about the top number is the number of dollars and the bottom number is the amount of windows, we know that Diego is actually earning $10 for every 9 windows that he's actually washing. So we need to go ahead and take a look at these values and see how do they compare to each other. Is $1 equal to 10/9? Or what is it? So Elena makes more money for making 10 calls than Diego makes for washing 10 windows. Consider those pieces. I think what you need to do is take one more step and find out what is his total earnings for one window. Here's my hint though. This is an improper fraction, and we know that every improper fraction is greater than 1. So choose the best options here, and we'll move on to the next question, the final question. Question 4, we have each square on the grid represents 1 unit on each side. Match the graphs with the slopes of the line. And so our job here is just to simply do what it says, to match the slopes. We want to, with the graphs, this is all we know, is that we can come through and find nice integer intersections, meaning we're finding a nice intersection between these where the lighter gray color lines actually intersect. And then we'll just do some simple rise and run. We'll rise on this one and run to here. Rise here, run here. And then what I want you to do is think about what is the pattern that's happening here in part A. In graph B, rising and running again, looking at those values. and make a decision. And then finally in part C, using a little bit of what we learned today, what happens when we go down and then to the right. On all the other ones, we went up and to the right. So we have to consider something. I will help you out with this one. Letter C, we remember that this is a negative slope. And then these two over here are a positive slope. And this is the last little piece that we talked about with this, about how we're moving from left to right this way. We see that our data are increasing over from left to right. So there you have it. There's your homework. Give your best shot. Really appreciate your hard work. Take care.